Hello students, in this lecture we will learn that what is involute profile of gear teeth. Okay, so in this lecture I will not particularly talk about what is a gear and how what is the power transmission mechanism of gear and different terminologies of gear. I will particularly talk about that in case we are using involute profile on the teeth of gear, then why we are using it and what is the principle behind that. So over here, let's see, this is a wheel, okay, and suppose a tangential force is applied at a distance r1 from the center of this is the axis of wheel. From the axis at a distance r1, a tangential force f is applied. So what is the torque developed on the wheel? It will be t1 equals to fr1. Similarly, in case the same force is applied at a distance r2, then the torque will be fr2, and at a distance r3, if we are applying the force, then it is fr3. Okay, and definitely t3 will be greatest. The torque developed in case the force is applied at a distance r3, tangential force, then it is equals to fr3. Since radius is greatest, so torque will be greatest. Okay, now think in reverse direction. Suppose this wheel is spinning and the associated torque of wheel is say t. So what is the tangential force developed at a distance r1? Definitely it will be torque upon that radius r1, and at a distance r2 it will be t by r2, at a distance r3 it will be t by r3, and definitely f3 will be smallest compared to that of f1. So keep this thing in mind. This is helpful in understanding the involute profile of gear teeth. Okay, now suppose this is a wheel. Again we are taking a wheel on which a thread is wound. Okay, and this is the free end of the thread. Suppose over here I am applying a force F, tensile force I am applying. So this thread will automatically orient itself somewhere in tangential direction on the circumference of the wheel. So torque developed on the wheel will be F into R. And in case this thread is unwound to some level and then the same force is applied, automatically the thread will attain a tangential orientation at another point of this circle, and the torque will be again F into R. And in case it is unwound to some more level and same force is applied, it will again orient at some point of this wheel in tangential direction, and F into R will be the developed torque. Okay, now in between, this is the free end of the thread. So in between these 3 points there are infinite such free end points. In case you are combining all those free end points, it is called as involute profile. Okay, now how involute profile is helpful? See, first of all, what happens in gear? See, gear is a toothed wheel, you can see, and the teeth are developed over the circumference of this wheel, and two gears are there. One will be driver, other will be driven. So the teeth of driven and driver are meshing with each other. So the driver gear actually provides power to the driven gear. Suppose I am taking this as driver gear. So what happens? The torque transmission takes place, the power transmission takes place by the help of these meshing gears. Okay, so remember this thing, when two gears meshes, there must be constant torque power transmission. Means what we want, that when one gear is transmitting the power to another gear, then torque must not fluctuate. Okay, there must be constant torque power transmission. If torque is not constant, it will result in velocity fluctuations. Means velocity of driver and driven both will start fluctuating, so it will lead to development of vibrations which can damage the gears as well as the system on which these gears are mounted. That system can also be damaged by those vibrations. See, these gear teeth have some profile with them. So that profile, in case we are using involute, then it is helpful for constant torque power transmission. So now we will learn about involute gear tooth profile in a lucid way. Okay, suppose that this is a wheel. You can see this is a green wheel and this is a red wheel. Okay, and on the green wheel as well as red wheel, some tangential links are coming out. Means these are some rigid tangential links which are coming out from these green wheel as well as red wheel also. Okay, now suppose you can see the end point of the tangent of green wheel is mating with the end point of the tangent of this red wheel. Okay, now suppose this wheel turns in clockwise, this green wheel turns in clockwise fashion, and the torque associated with this green wheel is say T1. Okay, then on this tangential link, what will be the force? Force developed at the tangential point on this green wheel will be F equals to T1 upon R1. Okay, because T1 is the torque, and we know this thing, torque is equals to tangential force into radius. Here R1 is the radius of this green wheel. Okay, so that force will be imparted on this green tangent, and this red tangent is ultimately connected to this red wheel. So the same force F, the same force will be transmitted tangentially to this red wheel, and the torque developed on this red wheel due to this thing will be T2 equals to whatever F is there into R2. R2 is the radius of the red wheel. Okay. Now this wheel is turning. Next we see another tangent. A tangent of this green wheel is connected with the tangent of the red wheel. Okay. Again the force transmitted will be same, that is equals to T1 by R1. So same force will be transmitted from this green wheel tangentially, and that tangential force is transmitted to this red wheel, and that also tangentially. So whatever force is transmitted F into R2 is the torque. Again the same torque will be developed, and this third link you can see, the next link, next green link, tangential link is connecting with the next red tangential link. Okay, so again the same force is developed on this green tangent, same force is passing on to this red tangent. The torque developed on this red wheel is equals to F into R2. Okay, so this is what the concept of involute profile. In case we are connecting the end point of these tangents, all those points we are connecting, as well as for this green tangent also, in case we are connecting, then this profile will be termed as involute profile. Because what happens in this case, if the driving wheel is imparting its force on the driven wheels, then the driving force is also tangential, as well as the receiving force by the driven wheel will also be tangent. Okay, so you can see one teeth has been developed on both the wheels. So this is the base circle. Okay, this is termed as base circle. On this base circle, tooth is developed. Okay, so this profile on the top surface of this tooth, red as well as green, okay, this profile is called as involute profile. Okay, so at last, involute gear tooth profile, what happens in case a driver gear is there, this is the driven, you can see the tooth are mating with each other. The tooth of driver is mating with tooth of driven. Okay, so at the meeting point, when driver is driving this driven, at the meeting point, in case you are drawing a line which is tangent to this driver wheel, the same line in case extended to the driven wheel, that is also tangent to the driven also. Means a line which is passing through the meeting point will be tangent to both the driver as well as driven wheels. Only then constant torque transmission will take place every time the tangential force developed by the driver wheel is received tangentially by the driven wheel. So constant torque transmission takes place. So hope by this small lecture you would have understood that what is involute gear tooth profile. Thank you.